Hello. I will talk about our experiences. So I will also talk a little bit about maintenance development in general, but especially from analytics point of view. I don't know how well you know Stora Enso. So few words about us first. So we are the renewables material company. Traditionally, we manufactured a lot of paper that is changing and has changed already quite a bit. So what we believe today is that all materials that are made out of fossil materials can be made out of trees tomorrow. And that's our business. We have extensive R&D ongoing to kind of move forward in different areas to materialize this. We are roughly 10 billion euros company in revenue, and we are around 26,000 people, mainly operating in Europe, but we have also production facilities in Asia and Americas regions. Maintenance development. If you want those results that are also visible in your balance sheet, in your profits numbers, then you need to have this sort of deep approach and address many different areas and layers when you then develop maintenance. Today, however, I will focus on the base level that is then close to analytics. So basically how you deal with the data-related challenges, what is kind of the analytics part, and also how you consume the results of the analytics. And I will show you a couple of concrete examples or talk about them so that you see kind of what we are doing and what we have achieved and what is still there to be done. So we start with data. So obviously you need to have data to do analytics. And we are very fortunate in Stora Enso because we have massive amounts of data. Most of our production is process industry related, and we have used data to manage and optimize our manufacturing processes for a long time already. We have detailed data stored typically in mills, and it varies a little bit from mill to mill. It can be a few years, but we have mills that have historical data of basically total performance of longer than 10 years. So we kind of can do analytics in many ways. But sometimes even that is not enough, and you might need to collect a bit more. For example, in areas that are not so critical to production, so there are still some equipment that are not censored and so on and so on and so on. And we use a lot cloud nowadays, so that means that you also need to move data around. So when I look at our mills, the first thing is their connectivity. And what is the level of fixed connectivity and what is the level of mobile connectivity? We need both. Typically within a mill, there are ways to move the data around. Typically, our control systems are connected to a central historian database. There can be several in one mill. But when you're then transferring that data to cloud, then the fixed network capacity is not necessarily enough. or at least it's not doubled. So if you're creating some critical solution and you are planning to run them from the cloud, then you first need to think about how you make sure that the connections are reliable, and if one connection is cut, then there is a spare one to feed the data to analytical solutions, for example. So this is normally the first thing you need to consider, and also in many cases you need to improve the current state. Then if you need to put more sensors to equipment, then kind of adding fixed sensors with cabling is typically very expensive. So you need some sort of radio technologies to communicate between the sensors and typically an edge device collecting the data. And then we have another kind of challenge. So what is the technology we should use to transfer the data? And typically there is already some mobile technology available or Wi-Fi available, but the coverage is not going to each and every corner of machine room, for example. Then you need to consider how you handle that. And as mentioned already, so you can use sensors that you then cable, or you use mobile sensors, and both have their own challenges, either cost related or technology related. But good example is that we actually co-developed a new type of sensor that didn't exist at all. We searched the whole globe and we couldn't find that sort of sensor we needed. And the reason was that there was a sensor like that, but it requires cabling. And to put one sensor like that to our machine room costs on average 1,000 euros. And typically you need 1,000 or 2,000 of those to cover the whole machine room. So it's way too expensive to actually add all those sensors you would need to kind of cover that. And those sensors are by the way, mainly for maintenance and safety purposes. So we developed a new type of sensor with a partner using modern radio technologies, and now the price of one sensor is less than 50 euros. So quite big difference. And it takes roughly 2 minutes to install the sensor and 45 seconds to commission it. So now we can actually have those sensors kind of spread to all places we need them. So kind of just give you an idea kind of how even the sensors and kind of collecting the data can make a big difference, how you can then measure maintenance related things. And this is just to give you an idea what sort of operating environment we have. So we have very big machine halls. Paper machine can be 0.5 kilometer long from start to end. Typically the width is around 10 meters, but the hall is actually much larger. So everything is big. It's heavy iron. So for example, radio signals, you need to think about how you kind of cover areas so that kind of the heavy metal is not in the way of signals, and you can really communicate reliably. Also, paper machine is always in two levels. So there's also a cellar where half of the machine is actually running, and between the levels there is a kind of thick concrete on top of which the machine is partly sitting. So that's about data. So we have a lot of data, but sometimes we need more data, and then we need to solve the problem how we get the data we need for maintenance analytics purposes in a cost-efficient way. Then analytics. I think we all have done, let's say, traditional reporting for quite a while already, and that is very important also in the future. So we are not forgetting that at all, but we are adding layers to it and different analytics. So obviously in relation to maintenance and equipment failures, root cause analysis is something we have done for a long time already, together with vendors, sharing data, for example. And we are now kind of running already predictive maintenance, not covering the whole fleet we have, but we have started the journey and kind of managed to get really good results with predictive maintenance already. Condition-based monitoring has been in place for a bit longer time already, and obviously we're using that data in analytics. But actually, where we are targeting at the moment is prescriptive analytics, not cognitive yet, but prescriptive analytics. And we have gotten very good results already in process optimization area. So we have certain AI solutions already running in our production units, but for the process optimization purposes. The example you see on the left side, that's actually a live system in our pulp mills, and it helps operators to maintain the quality of pulp before it's manufactured. So the solution sees roughly 12 hours in the future and gives operators enough time to actually make decisions how to change the process settings to keep the quality at the right level. If the quality goes too low, then customers are not paying full price. If it's too high, then kind of the product becomes costly and you cannot cover those costs from your customers. And the solution also suggests operators what they should do. So they really prescribe how you should change those process settings to get the optimal quality. And it also gives operators a chance to simulate different future possibilities. So if the operator doesn't believe that the algorithm is actually giving the best possible outcome, then the operator can by himself, with his long experience, go and kind of test different settings in a kind of safe environment, and he sees immediately the impact as a simulated future development. And then he can make decisions kind of how to change the settings or leave the settings as they are. These analytical solutions, no matter if they are in our process optimization or maintenance, they are currently not so-called closed-looped. So we are not giving these algorithms direct access back to control systems. So there's currently always a human being in between. So we provide advice to people how to do their work better. There will most probably be a point in time when we will also allow algorithms to kind of do settings by themselves. And eventually, a lot of these capabilities we are currently building with analytical tools will be kind of natural parts of automation systems, for example. But they are not there yet. On the right-hand side, you can see kind of how predictive maintenance looks in our environment, and we are currently developing, adding those prescriptive capabilities also to maintenance applications. If predictive maintenance is difficult, prescriptive is even much more difficult, because then you typically need totally new data sources. You need to connect maintenance management system data. As we heard earlier today, that data is not always very good quality, so you need to consider those things before you can then integrate these new types of data to the let's say process and equipment performance data. And then obviously if you have the data and you apply advanced analytics on the data, and you have very nice valuable working solution, then comes the consumer or consuming part of the analytics results. So if like in our case, we are providing tools for our operators, maintenance technicians, and other personnel, tools to kind of do their work better, advisory tools, then those tools need to be such that they actually use them and they are easy to use. And then you need to consider what is the user interface and how those solutions are used. And we have tested, for example, different realities, augmented reality, virtual reality, mixed reality. Unfortunately, these technologies are not mature enough yet for our purpose. There are, for example, safety concerns. So if people, for example, let's say a maintenance technician uses augmented reality and uses, for example, a smartphone, and if he then walks in a machine room looking at the screen, it's immediately a safety concern. So mobile in your hand, walking, that normally means that there is a danger of an accident. Especially when you are in an environment where you can hit your head, or you can tremble easily, or other things can happen. So we have tested. We are not there yet in technology sense, at least not in our operating environment. We have also talked with a lot of other companies, and for some companies, for example, augmented reality works pretty nicely already. Then devices. I mentioned smartphones. So that's kind of something that people actually want to use. So we have tried tablets, we have tried different wearable devices, but actually people like their smartphones. It's a kind of normal user interface today, and therefore we have kind of created a lot of tools that actually are mainly usable with your mobile device. For example, mobile maintenance tools we have had already for quite some years. So they are always in operators and maintenance personnel's pocket. So you can create maintenance notifications, you can create maintenance orders, you can report what you have done on a mobile device. Always, anywhere. But for example, these wearable devices, one example, in our machine room, the noise level is typically over 100 decibels. None of these wearable devices, HoloLenses or other devices actually works reliably in that sort of environment. Typically kind of the microphones and others, they just don't cope with it. Now we are seeing new versions of these wearable devices coming up. There's HoloLens 2, which is now designed, let's say, focusing on industrial use. We haven't tested it yet, but hopefully kind of certain features have been improved quite a bit. Because when we have, for example, augmented reality for maintenance work, on a wearable device that actually works, it will change quite a bit the maintenance work, and also kind of we will be able to increase productivity of maintenance work quite a bit again. Mobility already did one jump, and now that is potentially the second jump then what we will see. And then management. Obviously, if you want to improve things, you need to follow up. You need to have very good visibility to management where we are going. Are things improving? They are measuring performance based on euros. If there is no kind of extra euros coming out, then your development also most probably stops, or at least slows down quite a bit. So different kind of ways how you report. Also, visibility in that sense that we see that we need to connect more and more these equipment manufacturers to our maintenance network. We do maintenance by ourselves, or it's outsourced, so we do both models. And then we need sometimes, of course, equipment manufacturers help as well with difficult problems and so on. But in the future, it needs to be, let's say, much more easier to connect directly to the best experts that can help to solve the biggest and most difficult problems quickly. So we are testing this sort of fleet management reporting and visibility. We are testing different typically mobile-based collaboration tools. Point R is one of those tools, very flexible. You can, with your mobiles, kind of share screens, annotate video or pictures, and then kind of collect a team of experts to solve a specific problem. You can hear, you can see what others hear and see. So those sort of things are part of the management in the future. Then this management visibility, key performance indicators, and how things are moving forward. We have created also an extensive reporting suite of maintenance operations. We are looking the maintenance operations themselves, so how well we are doing maintenance. But also in relation to maintenance, we are measuring and following up, reporting the overall performance of the machinery, the equipment that we are maintaining. No matter if we do the maintenance by ourselves or it's outsourced, we want to see where we are going. And just by creating this very extensive, deep transparency to performance has improved things a lot. And we even go to personal level. Obviously, you need to give permission, but we can follow up individual maintenance technician's performance, how he's doing. It's mainly used for development purposes, so we use it in competence development and such let's say development activities. But that's kind of the depth we can go, and also width is quite covering when it comes to the maintenance operations in general. And then what we have achieved, this is actually kind of real performance. I cannot show you the kind of the exact numbers, but this is the trend. So this is how kind of the unplanned shutdowns or problems in our production lines based on technical reasons has developed. So these new capabilities, predictive maintenance, making sure we have enough data so that the predictions and also in the future prescriptions are good, and that whatever results we create from the analytics, then that's easy to understand for the people who are actually performing the maintenance, and also it's something that directly supports people's work, and in that way they are willing to use the tools, because the worst thing, of course, that can happen is that you put a lot of effort in developing these capabilities, these tools, and then if you don't win the users to your side and these tools are not used, then actually the value you created is negative. You only created cost and no benefit at all. That was what I planned to show to you, and then I left a couple of minutes for questions or comments as well.